So, on today's episode, I'm joined by Henry and Alex from Havenwise, which is a lovely little new sort of venture that's entered our industry, and we'll be chatting to them all about that. And I'm also joined by someone I call my expert consumer, Mick Wall. He's been on the podcast before. I think I titled it something like Expert Consumer. Mick's been doing lots and lots of good stuff. Um, in our industry. He's writing blogs. He's helping engineers understand sort of the intro. I always find it hard to say this word, interoperability between battery systems and solar thermal systems, as well as heat pumps. An excellent resource, and I'll put that in my show notes. So, welcome to the show, guys. Henry, tell us a little bit about what Havenwise do. Well, actually, you guys first you had a meeting with me probably last year, wasn't it? Because Alex had done some really interesting stuff with his own boiler. Alex, you've got a master's in engineering, and you're in the British Army, and you're very clever with all this AI and robotic stuff and coding stuff. And you had a meeting with me because you had a bit of an idea that you wanted to sort of help the industry with controlling heat sources, basically, didn't you?
Yeah, exactly, Nathan. So I think that is a bit over a year ago already, actually.
Mm.
So yeah, we started Havenwise a bit more than a year ago, but the underlying technology that Alex has built has been in development for 2.5 years already. But I met Alex during that period, and then we started Havenwise formally as a business after that. And we set out to make heat pumps easier and cheaper to run for homeowners, and to reduce the time that installers spend tuning heat pumps post installation. That's really what Havenwise is all about. That's what we do. What we do. And yeah, it started from an idea, but now it's a proper business. And the reason we started it is because we saw that a lot of homeowners were struggling with their heat pump controls. They're pretty unintuitive. They are difficult to understand. A lot of different technical parameters, very different heating concepts from a gas boiler, and so people are confused. Often, they have some discomfort, and they struggle with high energy bills. So that's what we saw on the homeowner side. And on the installer side, what we saw is that when installers set up a system, when they commission it and they need to set parameters like the weather compensation curve, it takes a while. It takes a lot of guessing as well, because every building is different. The people living in the building have different comfort requirements. If you commission a system in summer, it's different from commissioning a system in winter. And so for the installer, it's not necessarily easy. They have to go back perhaps a second or a third time to fine tune some settings, or they have to do it remotely via a web portal if they are lucky. But it is a time sink for them, and it's not easy. So that's really what we saw out there, Nathan. I don't know if that gives you a good overview.
So I'll come to you, Alex, because you were in the British Army, and my apprenticeship was with the MOD. So and you've got your masters in engineering, and you do all this weird stuff with robotics and AI. So just tell us a little bit about your journey.
Yeah, sure, Nathan. So, like you hinted at there, started off as a British Army officer, straight out of college. Actually, I didn't go to university initially, and had a great, very rewarding career there. But I soon had some other thoughts and ideas about what I kind of wanted from life. As I did a bit of a stock take, decided to go to university after all, and I studied for a master's in robotics and control engineering. And while I was on that journey, what I particularly fell in love with on that course was the control side, and also a bit of the software and the programming, which I was being introduced to at the time. And I was super lucky. I was super lucky while studying to have two particularly talented tutors and professors. One of them was a expert in control engineering, in predictive control specifically. He had a PhD from Oxford University, very, very talented mathematician. And he had a brilliant understanding of some really quite complex control algorithms and applying them in practice. And then I had a second very, very talented professor who was an expert in building thermodynamics, how they heat up, how they cool down, installation levels, all of that business. And as part of my final year master's project, I thought, well, I've got these two people I admire and I really enjoy working with. Wouldn't it be great if I could find some kind of way to combine those two things into a single area? And that research and that bit of work I did in that master's year really forms the basis of a lot of what we begin to do now today at Havenwise in terms of optimizing a building's thermal characteristics, the comfort inside that building, taking into account all the different attributes of it in a 24-hour future-looking optimization window.
I think when we first met, you built something to control your own boiler. Is that right?
Yeah, that's correct. Yeah, so the very first prototype was essentially I'd done it in simulation in that master's year, and I thought, well, it's worked here. It's worked in a simulation sandbox environment, verified building model that's accurately represents a real building. But the reality is, until you do things in the real world, as I think a lot of installers will know, anything can happen. There's the real world is very different to a computer screen. And so what I did is I thought, well, is there anyone I can sweet talk who I know, friends and family into hacking into their system, essentially their heating system. And yeah, I managed to find someone, talk them into it, and for a year, I ran the everything I'd done in simulation in a real world building, and the results pretty much followed the simulation results, which is really, really encouraging for then expanding that and scaling that system.
And I think when we first met, also you both sort of were chatting to me that you had the idea of making sort of a smart thermostat for heat pump control, and I sort of said, well, maybe not a smart thermostat, maybe an optimizer, and because there was a big sort of discourse starting to happen about optimizing heat pumps, and like you've just mentioned, Henry, the advantage of what you've now developed is there is an issue when someone commissions a heat pump system. They've got to set that weather curve. People, they like this colloquial term, dial it in, and they might have to revisit the property a couple of times to sort of tweak that to get it optimum. But your system now does that automatically, doesn't it? So that's removed that pain point for the installer, hasn't it?
Yeah, that's right. That's right. And indeed, Nathan, when we met about a year ago, we were debating a bit. Is it a thermostat? Is it an optimizer? What do we call this thing really? And then you said, don't call it a thermostat because people, a third party thermostat doesn't go well with a heat pump. So stay away from that naming. So yeah, since then we've been calling it more of an optimizer. But yeah, what you say is exactly right. It determines what the heat pump parameters need to be for that building, for that user, automatically. So the installer doesn't have to set it, or yeah, the consumer doesn't have to set it either.
Now, Mick, you as you mentioned on the podcast episode I had you on, you've got this lovely, wonderful system that's been installed by our wonderful, lovely friend Damon Blakemore. You've got solar panels, you've got battery, you've got a Mixer G, and you discovered Havenwise, and you've now incorporated it into your fantastic system, haven't you?
Yeah, and I actually got in touch with Havenwise after your episode with Ken Bone, where you were ranting as usual about thermostat, about controls, and it was absolutely bang on point. Uh, as I've got a Valent, and Valents are as one of the better controls, uh, and even what as as Henry says, configuring a system in the depths of winter, you can dial your weather curve in so that it gives the right amount of heat when it's 0 degrees outside. But the house behaves slightly different when it's 7 degrees outside and it's sunny. It still needs a bit of heat, but you're getting solar gain. A standard Valent controller or a Mitsubishi or a Samsung has no idea that it's sun shining outside, and it doesn't know what these external influences are. So even the best bog standard controller like a Valent can't adapt to everything, and that's where Havenwise comes in. It does a lot better job of load compensation, so it senses the indoor temperature, it knows what's happening outside, but it can sense it. It can react quickly. It doesn't. It's not a standard controller. Is like from a Valent or a Mitsubishi, the heat curve is just a predetermined line. At this temperature, do this. At this temperature, do that. But the beauty of Havenwise being remotely connected to your system is that it's constantly looking at these changes. Has the temperature gone up over the last hour? Do I need to make a change? And it adapts on the fly, which makes it so much better than a standard controller.
So, Alex, tell us a little bit about the technology. So it works with an API, does it, rather than a piece of kit having to be installed? So there are other optimization sort of products on the market, but I suppose a USP of, for you guys is no one's got to actually install anything extra. It's all done. I'm going to sound technical because I don't really know what API stands for, but have I got that right?
Yeah, you're on the right lines, Nathan. So API is application programming interface, and we're quite different, I'd say, to anything on the market right now. Very different, in fact. I mean, firstly, every optimization algorithm is different. Ours has obviously been developed in-house, and it will be the same with any other optimizers out there. We put comfort first and foremost, though, with ours. So anything the optimizer is trying to do to obviously save cost and the like and optimize that underlying weather compensation characteristics, comfort's at the center point, and we will never breach the customer's comfort requirements, as we call them. Those are the red lines, I think, for people. You know, everyone does want to save money and minimize their bills. Ultimately, we all do, but not at the cost of a cold shower, or the cost of waking up and it being freezing cold, or maybe even too warm at night. So we'll always work within those bounds. So that's the second area where we significantly differ. The third one is, as you say, as you hinted at, is that we use the APIs. So we're software only. So we're super, super easy to deploy. A lot of our users have set up and deployed Havenwise by themselves with no physical intervention by ourselves or an installer or the like. So we do pride ourselves on trying to be as easy to not just use in real time with the controls, but to be as easy to set up as well for the users. In terms of how it works in practice, the homeowner they get a very, very easy to use, simple to use app with which to control their heating. And it should look and feel quite similar really to how they would have used before with boilers and the like, which has been the heating system that's dominated certainly the UK previously. And this is critical because this is what people are used to and what they know. Most people aren't going to know about weather compensation curves. You start talking to them about it. And then if you start talking about time of use tariffs, their eyes will probably then glaze over. You know, it's a very new area. So they get a super easy to use interface. In the background then is where we have all of the algorithms and the optimization and the smarter control happening. And what we essentially do is we're looking ahead into the future. We take right now about 24 hours into the future, and we have a thermal model of the home that we've calibrated with measured data from that home. And so we know exactly how this home will heat up and cool down over that period, depending on whatever control we might use to do. And so, given the user's comfort requirements, how warm and cold they might need it to be, we can look ahead to what's going to be happening in the next 24 hours. And we can plot a path in that 24 hours that is the cheapest to meet those set points and keep them at the right temperature, taking into account all those factors with the home, tariff, etc., that we've discussed.
So that you've picked up on an important point I want to talk about there. So this isn't just doing weather compensation, which is something that just Mick's helped us all learn about. It's looking at time. It's looking at the tariff and the price of electricity. Is it?
Yeah, that's correct. And this is optional. So it's the users can decide whether or not they want to enable or disable this feature, which is quite key. Some people prefer it. Some people have solar battery, which changes really what their requirements are and what they want from the system. Obviously, if you've got a massive battery store, and maybe if you don't export back to the grid, then it's kind of you're not too concerned about when you're using that heat pump. But some people, particularly some customers who are on tariffs such as Cozy or Agile, use it to great effect.
How does it? So when someone downloads, I suppose they download it. A customer download this app. So how does it then start communicating with the heat pump? So for us novices around all this sort of communication type thing, how does it actually then start? And are there particular brands it can communicate with well, or are there some brands it's unable to communicate with?
So
Yeah, go ahead, Henry.
um, when people they download the app, and then there's a couple of steps to go through within the app to connect the heat pump to Havenwise. That typically involves just for instance, for a Valent like Mick has, they just need to post the serial number in our app, submit that serial number, and then it is connected to our systems. So that's really all there is to it. Next step is setting up the comfort requirements, so heating and hot water schedule, and then after that it's press the enable button. So it's all in the app. It is a guided experience, if you will, for the homeowner. They can do it themselves, or if the installer wants, the installer can do it with them, up to their preference really. In terms of brands, at the moment we support Valent, Samsung, and Mitsubishi, and we're working on a couple of other brands at the moment. So that should be released in the next few months.
Oh, brilliant. And is it easy for other manufacturers to incorporate your system then, if they want to?
Yeah, it's so if we look at the three manufacturers that I just mentioned, they didn't have to do anything to be compatible with Havenwise. And that is the same for all the other ones as well. It's more us. We need to do some work to ensure compatibility, and that just takes a little bit of time. And just we're working through the different brands.
Now, Mick, you're what I would call an expert consumer customer. You're very techie. You've got this app. Would you say it's very easy for just your average Joe homeowner to just use?
Yeah, absolutely, Nathan. It was so easy. I signed up to him. You go onto Havenwise site, register username and password, usual sort of thing. Get your Valent from most heat pumps come with their own app. There'll be a Valent app, there'll be a Mitsubishi app, there'll be a Samsung app. So most heat pumps have got some sort of remote internet connectivity out of the box. So all that Havenwise is doing is piggybacking, I can't even say that word, piggybacking on the back of existing connectivity within that heat pump. So provide your serial number of your heat pump, and it just appears in the Havenwise app, and you agree that Havenwise will then take control of that heat pump, and then you just let Alex's clever stuff do its thing. And after a couple of days, it learns your thermal characteristics, and then starts really hitting those target temperatures really sort of to the point. It's really accurate.
Now, your system is being monitored with our friends Tristan and Glenn, Open Energy Monitor, and that the heat pump monitor.org site has your system on it.
Yeah.
Have you found that this Havenwise product is actually helping now with the performance of your system?
Yeah, I think I would say that it's not made a vast amount of difference performance-wise for me, because my system was very well tuned by Damon, and
Yeah, yours was very good
I tuned
anyway.
it a lot.
Yeah.
But what I was instantly surprised and impressed by the comfort level. So as I just said earlier, the Valent controls are really, really good, but there are some days where it will overheat because of solar gain and things like that. But Havenwise will on a day when it is solar gain, it will drop off the flow temperature of the system to give you exactly 20 degrees if that's what you choose. It does a lot better job of maintaining that comfort based on all the inputs that are coming in. So some days on the Valent controller, mine might have gone up to 21.1, but Havenwise will keep it at 20. It does a lot better job. So ultimately, you use less energy, costs you less, and you're more likely to get better performance. I've been running it for about 6 weeks, sort of April time. So it's not been the the best time to see the ultimate performance when it's really cold, but it has really helped with those shoulder months where it's 7 degrees, 8 degrees, and you're in that strange time when the sun's out, but it's still 5 degrees, and you've got different inputs coming in.
Well, someone that has been using it for quite a while is Henry, Alex, and I have a mutual friend, don't we, David, who's a journalist for mainstream media. And I think we've all just been mentioned in a recent article, Telegraph Money, is it? Have I got that one right, Henry? Because he's been using it for a while. Very super impressed with it, isn't he?
Yeah, David was one of our very, very, very first users. We were chatting on the Open Energy Monitor forum, and he was essentially asking, I'm on Octopus Agile tariff. How can my heat pump be aligned with the tariff, making use of the cheaper moments and avoiding some of the more expensive moments? And I was like, well, that's exactly what we're trying to do, David. Do you want to give it a go? And so he was one of our very, very first users. So he's been using it for more than a year, I think now. And yeah, the results have been very good. I think the results have been good both in terms of the reduction that we got versus his situation before, but also just versus a gas boiler in general, in terms of cost savings and comfort. And I think Mick touches upon a important point. A lot of our users use Havenwise for the cost savings, and so I had a chat with Mick before he started using Havenwise, because he is a little bit of a special homeowner, let's say. And Mick told me, well, look, like my system is like tuned exceptionally well. Damon installed it. I'm very deep on the controls, and he is like, I don't know anyone who knows the Valen controls as well as Mick, and he has like explained all of that in his blogs. For him, the main point was comfort, and so it's nice to see that even in a situation like Mick's, Havenwise can still help. So that was, for us, it was a challenge. Like, can we really be better or improve the situation that the heat pump was in before, knowing that it is like an exceptional system. And I'm just happy that we were able to do that.
Alex, is it hard to write algorithms that do all this sort of control? I mean, is it an easy process? I don't know.
No, it's not easy. There's so many factors with a heat pump that you need to consider versus, say, a gas boiler. I mean, you've done some brilliant, work and highlighting even with gas boilers, Nathan, how we haven't been using them properly in this country. We haven't been using weather compensation properly. We haven't been matching the thermal loss of a building to the amount of heat energy that needs to be put in. And that's true even with a gas boiler. I guess with a gas boiler, though, the penalty for doing that was far less than it is with a heat pump. And therefore, when you're then optimizing for a heat pump, there's so many variables you need to take into account of, from the thermal mass of that building, how well insulated it is, how big the hot water tank is, the people inside, their habits, how warm and cold they like it to be. And then you're throwing in these days things like grid constraints and energy tariffs and the like. And it's a lot. It's a lot you have to optimize for. But this is what we really hope and want and feel we do take away from the homeowner and the installer, is we abstract all that complexity away and we just let them say, how warm do you want to be and when? And that's all they need to input into the interface.
Before I forget, I'm going to come to you in a Mick regarding hot water, because Mick has a Mixergy system, so I want to know if it's sort of how it sort of kind of works with that. But going back to your point, Alex, are you learning anything more? So is in the future, are we going to see Havenwise? Are you developing your algorithm all the time? For instance, is there other things you want it to do? Do you think, or have you cracked
Absolutely.
it? Yeah.
Absolutely. Yeah. We're always looking to improve it. frankly, I always have a longer list of things I want to improve with what we do. We have, and one thing we pride on, and some installers think we're a bit crazy for doing this, but we have a direct link via WhatsApp usually to all of our users. And some of them are super active, super engaged, such as Mick. And we were talking about just a couple of weeks ago actually on improving how it operates with respect to open doors, open windows, things like that. Those kind of transient things in the nicer weather we have, where perhaps you want a bit of fresh air going through the building. And we take on board feedback like that all the time, and we try and act on it when we can. And we also, via that direct WhatsApp link to the users, we have some people who are obviously far less, not, in fact, it's a minority of people who are so good at energy and heat geeks such as ourselves, um, tend to communicate with us less, but they have that communication channel available for features, suggestions, feedback, or when there's any issues.
So
Yeah,
I
that
think that's
Nathan,
also
Nathan, just I have to publicly apologize to Alex and Emery for the amount of graphs and data that I fire at their WhatsApp on a regular basis, saying, "Why is it doing this?" And Alex alluded to then about open doors and open windows. Uh, it was sort of 12 degrees and really sunny a couple of weeks ago, and my wife was sat out in the back garden with the patio doors open and the heat pump was still on. And like there was this big spike, and I sent this graph over to Alex, and we were like, how can we best deal with this? So Alex is right. There's going to be constant evolution, but having all those data points, you can look to make the product better, and understand why something happened.
sort of like my peer-to-peer learning that I often discuss. And you're all learning from each other, discussing your different use cases. So talking about the hot water, I mean, is something that you've helped the whole industry around. Really, you've got this Mixergy that Damien put in, and you've been helping people learn about heat pumps and the hot water side as well. So, is it working really nice with your setup?
We decided not to. I've not gone down the hot water route yet with it, uh, because I'm an odd case. I use my I've got other ways of controlling the hot water and time of use tariffs, so I'm already embedded in my own sort of thing. So, uh, as Henry said earlier, the weather there's certain parts of the system, the Havenwise system, that you can toggle on or off. So you don't have to use time of use tariffs. You don't have to use the hot water side of it. You can just use the heating. So I just decided to turn off the time of use tariff and the hot water control, and I've just concentrated on the heating. So, but looking at the menus and the options available, I would say that the time of use tariff element in Havenwise would be as most benefit on the hot water side, because that's your big sort of thing. And if that's your big output of the day, and if you can shift that to a time where the energy tariff is way cheaper and it's all it's all done for you by Havenwise, and you don't have to look at a graph saying, I see that at 2 o'clock this afternoon it's only 1p per kilowatt hour, I'll schedule something. Havenwise does that all for you. It just says, right, we'll do your hot water this afternoon because it's going to be the cheapest and best for you. So yeah, that side of it would be a big win for a homeowner who isn't as geeky as me.
Now, one of the sort of the great features about this, which I've alluded to earlier, is it saves time for engineers because if their customers are going to use Havenwise, they can get this whole thing of weather compensation dialed in very accurately. So that helps installers, it helps installation companies because they haven't got to go and do repeat visits. Do we know if engineers are kind of being trained at the moment? I mean, it's a bit of a rhetorical question, but are they being trained at the moment around sort of products like what you've got that helps them because a lot of engineers that are going on heat pump courses, it's the first time they're hearing about weather compensation, despite it's been around decades. But are you aware of anyone being trained in sort of the device and the optimization capability of your offering?
not immediately, Nathan. It's a good question. So like we explain it to installers directly, but we don't have like a formal education channel or link to them when they enter the industry. Um, and so that is a journey for installers because they're used to something already. They're used to going back 2 or 3 times post installation. That's how they have been doing things. And so we take installers on a journey to explain what Havenwise is. Then we try it with them on a few systems so that they can get used to it, and then afterwards they start using it with all their customers. That's typically what we see. It's a journey. We do need to explain it to them. They do need to see it in practice, working. But it's also good that we have cases like Mick, like David, who then also publicly share their experiences and build a bit of trust in the brand. But yeah, that's a big journey for us, Nathan.
What I might do is
Nathan, when I posted up that I'd been using it for a week or so on LinkedIn, the amount of installers that replied, watching with interest, was quite telling. That, as you say, they don't want to be going back to site 3 and 4 times to tweak a weather comp curve, and they shouldn't expect the homeowner to understand weather compensation curves. So having something like Havenwise that on a day-to-day basis just nails the indoor temperature, that's all a homeowner wants. They want a fire and forget system. I think most heat pumps out there at the moment don't provide that. Some of the poor ones definitely don't provide that. So, and as you say around training, I think a lot of installers don't know how to do that well as well. So Havenwise ticks a hell of a lot of boxes for a lot of people.
well, controllers they're complex. They're definitely complex for customers. You ideally don't want your customer having to do anything with them. I mean, I know you like twiddling me, but they're also complex for engineers, especially if they're having to get used to a sort of a variety of models because they're using different makes of heat pump. Whereas, one question I want to ask is: are you guys members of the Heat Pump Association? Because if you're not, that might be beneficial, and I'll hook you up with the CEO of the HPA because you can become a full member relatively cheaply. Because and the other person I'm going to hook you up with is the CEO of BPEC. So a lot of the courses that are going on around this country, the heat pump courses, I think it would be beneficial if the instructors, the trainers and assessors mention a particular kit like this because it attenuates the fear that some of the people coming away from them courses might think, oh crikey, this sounds complex. Never heard of weather compensation. I don't, the controls I use on boilers are complex enough. I don't really want to get involved. If they know something exists which completely helps them and takes away all that pain for them, I think it's very, very important because then we're going to get more people going on this training likely to then think, right, yeah, I want to get involved in installing heat pumps because I've now got something that can help me do that. So I'm going to hook you up with Neil, who's the CEO of BPEC, who run they and LCL Awards do it, so I'll hook you up with LCL Awards as well.
Yeah, that's brilliant. I mean, if we can embed it in trainings, and it gives installers, more comfort and more certainty and more trust, confidence in themselves to deliver a good install, then we're all for it.
And have you got so you obviously chat to the individual engineers that are sort of you're starting to get to know, but have you done any training webinars that are for engineers to help them learn about this?
Yes, but specifically for company by company or installation company by installation company, if you will. We haven't done like big public webinars. That is something we actually spoke about internally, so that might come quite soon.
Well, if you want any help with that, I'll help you because I think it's a really good initiative. I really like it. I like the fact it can help, like I say, attenuate some of the fear that some of these engineers are having. Because obviously a lot of engineers think, oh, what is this? What is this weather compensation? What does it all mean? And I think if there's a nice, simple bit of training, and then it's also within that training, it says, look, you've got a product like Havenwise that can really help you. You haven't really got to do anything. You haven't got to really go and start tweaking about with the control and get worried about what functions you're pressing because this kind of does it all for you, doesn't it?
Yeah, Yeah, yeah. There's one other thing, Nathan, it's something you touched upon like a little bit ago, which is, um, the one of the issues with the controls of the manufacturers is that when they design a new control for their heat pump, the design cycle, the development cycle is just very long. It takes them 5 years to develop a new controller, and then it's in the market for 5 years, and then maybe they'll do the next version after that. So that iteration process is just so slow, and that is also one of the reasons why we've gone software route, is that we can just be very quick. Like if we make a change, now, it is deployed for all our users, in the next 5 minutes. So that is one of the things I think that as an industry we should like see, what we can do faster, for installers and homeowners, because the challenge to ramp up heat pump installations is real. And I think speed is important.
Robotics, Alex. You've studied robotics. Are we going to see robots in this industry anytime soon?
Maybe not the very near future. I think it's very hard to replace the really bespoke and expert knowledge that installers need to have, when they're putting these systems in. And we always say what Havenwise can do for people is, we can make a system as good as it can be, as that installation quality was. But ultimately we can't replace a poorly sized heat pump. We can't change any pipework that may or may not have been replaced, or change radiator sizing. And we have been connected to some systems where it was evident maybe that when it went in maybe one of the schemes which kind of encourages the heat pump just to be put in and almost forgotten about. And you can see the limitations there. So, some systems, unfortunately, if they're not installed so well or designed so well, then we can only get the most possible we can out of them. So in terms of would we see robots anytime soon? Not in the immediate future, because it just requires such an expertise, such great knowledge from installers to get that part of it right.
Mick,
Nathan,
go
sorry,
on.
I keep interrupting us on. What I'd like to play devil's advocate, and on the back of something Alex just said, is that we don't want Havenwise or any similar sort of optimizer to mask a bad install. We still need the training and the pipe sizing and the index circuits and all the things that the installers need to know and need to do well. I suppose what we're doing with Havenwise is you're just giving them the confidence to not need lots of visits to dial in the comfort. That the fundamentals still have to be there. And as you bang on all the time about training, that absolutely has to be there. So yeah, we don't want to be masking bad work, do we?
I would even go one step further, Mick, which is, if you think about the whole journey of a heat pump install, Havenwise addresses the very end and then the running. But actually, for an installer, the biggest chunk of work and expertise and training that they need sits before Havenwise even gets involved. And yeah, absolutely, that's also where a lot of the impact on performance is created.
Does it? We've talked a little bit about how it starts to learn and understands the particular home, doesn't it? It's learning kind of the thermal comfort of the home. Is it able to tell people the performance of a heat pump? Like obviously, what the terms people use are COP and SCOP. Is it able to do that?
Yes, so we do. That's a change we made in the last month or so. So we now do make that available in the Havenwise app as well. So people can see the COP, people can see the actual cost for the heat pump as well. So based on when it was consuming and what tariff you're on, people can now see that as well. It doesn't take into account yet the effect of solar PV and battery on the cost calculation. But it does, for instance, take into account solar PV for hot water cycles and the like. But so yeah, that data now, Nathan, it has started to flow back into the Havenwise app so that people can see that.
And would it be as accurate as the MID stuff that, like, obviously Mick's got on his system? Because I suppose it's relying on the sensors within a heat pump, isn't it?
It is based on the manufacturer data. It is not independent. So it is not pulling data from Open Energy Monitor. If people have that, for instance, yeah, it is the manufacturer data, which has, as we all know, has limitations, but is often good enough. Is what we see.
Nathan, I've just pulled mine up. Here's the big reveal. So my Open Energy Monitor system in the last week says I have had a copper 3.66. Havenwise says 3.68. Now this isn't staged. That's I've just pulled those windows up. So there you go.
This is what I call Mick, my expert consumer. So now, as we know from you, people like yourself, and Tristan and Glyn, we sometimes there's systems that their internal monitoring is kind of matching very, very closely to the certified measuring equipment that they use, and then for whatever reason, sometimes you'll get a model that is slightly out, isn't there?
Yeah, because with Open Energy Monitor, you're using billing grade heat meters, temperature sensors, and electricity meters. But obviously, to keep costs down, that higher class of device doesn't go in a heat pump. So you get cheaper flow meters, cheaper everything really. So the tolerance of accuracy can be way out. And also, it's been known that on some heat pumps, that how the sensor has been attached to the pipes within the external unit is poor. So the contact's not there, the readings are wrong, so all the things are out. So yeah, the monitoring within heat pumps sort of out of the box can be good, can be poor. So
yeah, that's true. I think it's the variance sits mostly on the heat output side of things. The electricity input is often quite accurate.
yeah, I suppose it's because it's easy to monitor, Henry. It's the heat output
it's tricky.
Is flow minus return times flow rate times, and then if one of those elements of the calculation is wrong, the whole thing blows up.
Yeah, and you have a pretty, you can have a, let's say you have a delta T of 5. If you have a 1 degree wrong measurement on flow or return, that's a pretty big delta that you'll have on the heat output, and that weighs on the cup. So that's typically where the errors come from, is the heat output, and a combination of just cheaper sensors, but definitely also quite often, a sensor is only as good as it is installed, and we've seen weird things in the data where we were like, maybe you should check your return temp sensor because it just seems to be picking off the room temperature, and so it wasn't attached. So we've seen those things as well.
But that's a good point though, Henry. By having this remote monitoring, you can see problems. It sort of highlights to the homeowner that there could be issues with something.
Yeah, we had a case yesterday actually where we saw some weird patterns in hot water temperature, turns out that the hot water temperature sensor is faulty. So that it helps to spot those anomalies in the data.
When you say spot, Henry, are you and Alex actually looking individually at the data, or are you going to start to build, as you scale up, are you going to start to build sort of AI systems that are looking at all this data and then trying to extrapolate certain signals that you're seeing?
So we have started doing that already. So at the moment it's a combination. So we have built systems that automatically spot weird patterns in the data, and then that helps us to then go into these cases and look at what's going on here in a bit more detail. So let's say our systems and our AI spots the weird things, but then a human looks at them.
Yeah, I love it. Have you guys been entered for any awards?
Say that again, Nathan.
Have you been entered for any awards for your product?
Not that we're aware of. It's not something I mean, we are a small company, so we need to spend our time with homeowners and installers, and we choose to not spend our time with awards and all these things
Well,
because
awards are really, really funny in this industry, and I've earned my stripes to be quite critical of them. So I'll probably get people commenting on this, but it's very good that awards. There's a lot of marketing companies, PR companies that do awards in our industry now. They are marketing devices, but some really good companies do win awards for their innovation. Others win them that probably they're probably not doing that great a thing. But I definitely think you guys should enter an award. It will help people it will help create awareness because it is a good product. What you're doing is really, really good. There's a few things I like about it. It's the fact that no one's got to go in and actually install anything. I did a LinkedIn post not so long ago about we should be installing less stuff. Been a little bit critical. They're great large installation company, but they're overusing fittings as far as I'm concerned. We're supposed to be using less in a sustainable world. And I like the fact that no one's got to actually install any hardware. It's all done very seamlessly with an API. Is an API and an API? That's the same thing, isn't it? So, but no, I really, really like it. I think it's got huge potential. If you need any help as well with hooking up to some heat pump manufacturers, obviously I know the sort of the MDs and CEOs of some of these manufacturers because it is a good thing for installers to have that reassurance that something their installation that they've took time and care about putting in, whether it's the pipe work they've been doing neatly. When it comes to control, some of them do get a little bit confused because that's part of the commissioning process, and some of them fall down at that part. Whereas if there's something that can actually help them with that because it's doing it all automatically, I think it's a great benefit to them and the industry.
Henry, could an installer not do any commissioning, just have the Valent or any Mitsubishi controller, do nothing to it, plug Havenwise in, and within 2 days it will have sorted itself out? Because that's ultimately the dream, I suppose, from an installer point of view.
Yeah, almost, yes. So at the moment they do need to do a few things, but a lot of it they don't have to do. But yeah, that's ultimately also what we're working towards, Mick, is that they just they install, they turn it on, and it commissions itself essentially.
Yeah, automatic commissioning is going to be a big benefit, I think. In terms of scalability, obviously you're going to get your sort of real geeky installers like Damon, Mick, and I know. They're going to really want to be involved with their own systems, and they like going back to their own systems actually and sort of tweaking it, seeing it, and learning about. Coming to this thing of it's learning about the home. So can it tell us heat loss, for instance?
They can, yeah. So all of the underlying machine learning that's going on, it can be post-processed to begin making some deductions about that install, such as the performance it would have at design conditions, expected heat loss for the home, etc., etc. None of that is available yet in any kind of interface or front end, say, app for people, but all of that is possible, and we've done some of the like derivations for that, if you will, and looking at some of that ourselves in the back end.
Why do you ask the question, Nathan?
Well, because I've been a bit of a big advocate, and funny enough, that's how I got to know David Strahan, who's the journalist we've discussed. I was invited to give evidence at a policy commission board. Ofgem were there, and Bayes at the time, and the Climate Change Committee, and I sort of gave evidence on behalf of sort of the heating industry, I suppose. And I was talking to people about how we're seeing a change again in industry. So people did used to do heat loss calculations. They've been done for donkey's years. You'd have whole departments involved in doing them. And then obviously we had our MERS calculators, and then it kind of sort of dropped off. People weren't really doing them. That's kind of with the advent of the combi boiler. And then there was a big sort of re-emergence of people and engineers doing heat loss calculations again. Now, calculations are really hard to do because you're making a lot of assumptions. There's all sorts of assumptions, even if people are very, very good at doing the calculation. So I was a big advocate of measurement, and actually measuring the heat and transfer coefficient of a building. And I introduced David, who was the author of this policy report. So he sat in the meetings and he was the one taking the notes, and he got hold of me. He said, Nathan, what you've just said about that really interests me. So I hooked him up with two companies at the time that were actually measuring heat loss as opposed to calculating it, because they are two different things. So any device that's able to kind of measure, I mean, even measuring heat loss is actually quite hard to do. I mean, Leeds Beckett did a lot of stuff back in the day around it. But it sounds like your system can actually help measure and get some information around the heat transfer coefficient of a home, which I like.
Yeah, I'm asking exactly right. I'm asking the question of why you asked it, because we've had quite a number of installers ask us the same question, and they're interested because they want to compare their calculated heat loss against the actual heat loss, and then they want to feed back the learnings from that into their design process. That's why installers have been asking us. So I think that's hearing you talk, that's exactly what you're after as well.
Yeah, because there's a lot of heuristics involved with so let's say, for instance, I grew up in a particular area of England, so I'm pretty au fait with some of the buildings in my sort of local vicinity. So, even though I'm measuring up, so the actual measuring doing really when you're doing a calculation, you're measuring surface area of your walls and window. Then you start to make some assumptions because you don't really know what's in between the wall. You don't know how well the insulation was put in. Your calculation is going to kind of say, that the whole cavity is insulated, but you don't know how well it was put in. You've then got the assumptions of U values. So even though U values, these numbers we use, in their own right, they are average numbers. They're the mean or median of some measured stuff, whether it's done in hot boxes or the BRE. So there's lots of assumptions, and of course, over time, when you're making your calculations, you're sort of making some assumptions. And if the engineer has a bit more of an accurate measurement to then sort of compare that to, you start to learn whether your assumptions are quite correct. And you start, so I think it's quite important for the engineers, they're starting to learn. Yeah, I got that one quite accurately, because it's a lot of engineers are sort of being criticised at the moment because some customers will have, let's say, three companies come round and do a heat loss calculation, and they are all going to be different, and that upsets the customer. But they are always going to be different. It's very rare you would ever get a calculation to punch out the same exact number. It's virtually impossible, because with a calculation you're just making very, very informed judgment, really. And obviously some are better than others at doing that, and that's where I think the real conscientious engineers love this thing of what your device can do, because it kind of gives them some feedback of how close they were.
I mean, air change rate is the most notorious, I think, isn't it, for the areas and ventilation for the property. It is so variable. Take the building you just mentioned, the guy you reference. I think they live in a terraced building, and so how warm do the neighbours like it? Are there neighbours? Is it a holiday home? Is it vacant part of the year? But if it's going to be vacant part of the year, then you actually have a building with a variable heat loss, really, because what you essentially have is a outside wall for half the year and then an internal partition wall the other half of the year. And so the heat loss actually varies. So it's an incredibly complex thing. And I think even some of the best intentioned and most experienced designers will struggle sometimes with it, because of that. It's not an exact science. There's a lot of guesswork that goes into it because you can't see through walls, you can't measure easily ventilation and the like.
Nathan, you'll be happy to know that 2 weeks ago I asked Alex, can you calculate my HTC from this data?
You've done it yourself based on your open energy monitor data as well.
Yeah, I cheated because I already knew it, but I was just wondering if you knew it.
You're such a geek, Mick. And before we go, Mick, like I said earlier, you write these fantastic blogs that's really been helping the heating industry. So thank you again once for that. What's your next blog you're working on? Is there something particularly you're working on or thinking about working on? What goes through that?
It's gone a bit quiet. I published my third winter with our heat pump blog about what it costs to run and the performance and lessons learned. So yeah, that's the most recent one. Maybe, I don't know, maybe there'll be a Havenwise blog post. I don't know. We'll see how that goes.
And also, I should point out, Mick, I've just introduced Mick to my big cousin that I often talk about, who's been putting heat pump systems in for nearly half a century. So my cousin's gone full electric. He's 76. He's just retired. He's just put his battery system in. He's had his solar system put in. He's going to put a full VRF system in his home, but he wanted a hot water solution. So I said, well, talk to Mick because I think the Mixergy will suit you. So I've hooked him up with my cousin who can, like him, uh, talk really, really sort of eloquently about what their own specific sort of interests. Guys, thank you ever so much for coming on. I'm really interested in your technology and sort of learning how you sort of progress in the future and how you can help the engineers and homeowners, even the geeky ones like Mick. So I think what you're doing is really great. Thank you ever so much for coming on. I'll hook you up with some of them people I mentioned in the podcast. And Mick, once again, it's always a pleasure to hear your lovely accent as
Thank
well.
you. I'll see you in person at Installer, no doubt.
Oh yes, are you guys at installer? Havenwise at installer?
Yeah, we will have a stand at Installer. Yeah, we'll be there for the whole duration.
Do you know the stand number?
Not yet, no.
Okay,
At least I don't know it. So I'm sure it's somewhere in my inbox.
if you find it, I'll put it in the show notes. Thanks ever so much, gentlemen, for coming on.
Thank you,
Thank you.
Nathan. Cheers.